Have you ever stopped to think about what the cloud actually is? I mean, really think about it. It's not some fluffy, magical thing floating up in the sky. Nope. Today, we're going to pull back the curtain on Amazon Web Services, or AWS, and really deconstruct it. We're going to reveal the incredible physical and digital infrastructure that powers pretty much everything we do online. Okay, so here's our roadmap for today. First, we're going to completely shatter that cloud metaphor. Then we'll get into the absolutely massive global foundation it's built on. From there, we'll dive into the core digital building blocks, the fun stuff. Then we'll figure out how to connect and secure them. And finally, we'll put it all together to assemble a real-world application using the best practices in the industry. Let's get into it. All right, first things first, let's talk about that word cloud. It's honestly a brilliant marketing term, right? But it kind of hides the incredible engineering that's really going on behind the scenes. So to truly get a handle on AWS, we have to look past the metaphor and see what's actually there. I mean, we hear it all the time. Our photos, our work files, our movies, everything is in the cloud. But what are we really saying when we say that? What does that phrase actually mean? Let's break it down. This right here shows the two sides of the coin. On one hand, you have the idea, this abstract, almost magical place. But on the other hand, you have the cold, hard reality, a massive, and I mean massive, global network of physical data centers. We're talking buildings packed with servers, all connected by thousands and thousands of miles of fiber optic cables. Understanding this, that it's a physical thing, is the absolute key to unlocking everything else we're going to talk about. So just how big is this physical machine we're talking about? Honestly, the scale is just mind-boggling. This isn't a server humming away in someone's closet. This is a planet-spanning infrastructure. Let's take a look at the numbers, because they really tell this story. Okay, so at the very highest level, AWS is organized into what they call regions. Think of these as totally separate geographic areas, like Northern Virginia in the US or Frankfurt in Germany. With over 32 of these placed strategically all over the world, AWS makes sure that data can be close to users, which means lower latency and also helps companies meet local data laws. Now, let's zoom in a little bit. Each one of those regions is actually made up of multiple isolated locations called availability zones, or AZs. The best way to think of them is as separate, totally self-sufficient islands within that region. Each one has its own power, its own networking, everything. This design, with more than 100 AZs across the globe, is the secret sauce to building applications that can withstand almost any failure. And to get content like videos and websites to you at lightning speed, well, for that, AWS has a network of over 400 edge locations. These basically act as mini hubs that store popular content closer to where you are. They're all connected by a private, super fast fiber network that completely bypasses the sometimes slow and congested public internet. And the result? A way faster, way smoother experience for you. Okay, so we've seen the physical foundation. It's huge. Now, let's step inside those data centers and discover the core services. I like to think of these as the digital Lego bricks that developers use to build literally any application you can think of. When you boil it all down, almost every single application is built on three main pillars. You've got compute, which is the brains of the operation. You've got storage, which is like the filing cabinets for all your data. And then you have databases, which are the highly organized records within those cabinets. When it comes to compute, you've got a whole spectrum of choices. On one end, you have Amazon EC2. This is your classic virtual server. It gives you total control, which is perfect for really complex applications that have very specific needs. But on the other end of the spectrum, you have AWS Lambda, which is serverless. You literally just upload your code, and AWS takes care of all the server management for you. It's the ultimate inconvenience, and it's fantastic for event-driven stuff. And you see that same principle of choice when it comes to storage. If you have data you need to get to all the time, like images on a website, there's Amazon S3 Standard. But what if you have stuff you need to keep for years but barely ever touch, like legal documents? For that, there's S3 Glacier. It offers incredibly low-cost storage, but the trade-off is that it takes a little longer to get your data back. So you've got your compute and you've got your storage. Awesome. But how do you connect them to each other and to the outside world securely? How do you control who gets in and who stays out? Well, that's where networking and security come in. The absolute cornerstone of security on AWS is something called the Virtual Private Cloud, or VPC. Just think of it as your own private, isolated slice of the AWS cloud. It's like a digital fortress where you control the drawbridge and you set all the rules for who gets to come in and out. So how does a request from a user actually get to your application? Well, it's a lot like going through airport security. First, it comes in through a designated gateway. Then, a route cable acts like a traffic cop, directing it to the right terminal. Next, it has to pass through not one, but two layers of firewalls. First, network access control lists, and then security groups. Only after passing all those checks can it safely arrive at your application. It's a multi-layered approach that we call security in-depth. Okay, this is where it gets really fun. We've seen all the individual components, the global network, the compute and storage options, the security layers. Now let's put these pieces together and actually assemble a real-world application.
Right. I mean, knowing all the parts is one thing, but seeing how they actually fit together to build something useful, that's where the magic happens. So let's take a look at a standard 3-tier web application. This is a battle-tested, super common architecture that countless companies use every single day.
This table perfectly illustrates that classic 3-tier pattern. You've got the web tier, which is basically the front door. It uses a load balancer to manage all the incoming traffic. Then you have the app tier, which is the engine room. It runs the application's actual logic, maybe using a service like Amazon ECS for containers. And finally, you have the data tier, which securely stores all the data, using a managed database like Amazon RDS. This separation is great because it lets you scale and secure each part independently. So having the right tools and a solid blueprint, that's a great start. But how can you be sure you're building in the best possible way?
Well, luckily, AWS actually gives you a framework to guide you.
It's called the Well-Architected Framework. And it's really important to note this isn't a tool or a service you pay for, it's a guiding philosophy. It's basically a summary of all the lessons AWS has learned from reviewing thousands and thousands of customer systems. It is their official playbook for building world-class systems.
The whole framework is built on these 6 pillars, and they're designed to make you ask the tough questions. Things like, are our operations automated? Is our security truly robust? Can our application actually handle failure? Is it efficient? Is it cost-effective? And these days, is it sustainable? These pillars basically act as a comprehensive checklist to guide every single architectural decision you make. And just like that, our architectural tour is at an end. We've gone all the way from the literal concrete and steel of global data centers to the elegant principles of world-class design. The building blocks are right there, at your fingertips. The knowledge is here. So now the only real question left is, what will you build?